Hello everyone, this is our ninth lecture and topic of today's lecture is estimate for RCC slab work. In our previous lecture, we already studied about approximate estimate and detailed estimate. In detailed estimate, we have also find the RCC work quantity. So here we discuss uh, lecture on RCC slab work. In this, we have to find the quantity of concrete and quantity of reinforcement. So, this is our numerical problem. Consists a room has a clear dimension of 3 meter into 8 meter. It has an RCC slab as shown in the figure. So, here we have given RCC slab diagram. Then wall is 230 mm, both side wall is 230 mm, 12 dia bars, 120 center to center distance, 3 meter clear span है, means width 3 meter है and length is 8 meter and 12 diameter alternate bent of parts है and the thickness of slab is 12 So first we have to know different length of bars. So how we find the length of bars and how we find the concrete discuss in our further slide. Before that, you have to know how we find the x value, means from that point to that point how we find, because this value we used in our abstract table. That's why first we discuss this diagram and how we get this 0.45 d value. So for that, what we have to do, we have don't know this value d, but we know that this angle is 45 degree. So we take a cross section of this diagram. So here is the cross section of the diagram. We know that this is the perpendicular, this is the base, and this is the hypotenuse. So we assume h is equal to x. Now we have to find the x. Actually thing is that from that point to that point we called as a d, but this is the inclined line. That's why here some part is the remaining. We called as a cd from this point to this point, and the remaining part is the d. So how we find that? So first we take the p upon s. So p upon s is equal to sine theta and x is equal to d by sine theta. We simplify that and get 1.414 d or 1.414 x. Okay, so here we get the value. Now we have to find this value. So tan theta is equal to p by b, and after simplifying we get d as a length. So additional length is 1.414 d minus d is equal to 0.4 d 42 d, and we approximately called as 0.45 d or 0.45 x. Here d is the vertical distance which we measure from this side to this side, or we get 0.45 d, means 0.45 d is the value which we remaining in our this part. This is our inclined part, because up to this point, means if you take a arc from this point to this point, so this value and this value is d, and remaining one is the 0.45 x. Now in our abstract, one thing more is used, that is the per meter weight of reinforcement. So how we find the per meter weight of reinforcement? We know that weight is equal to volume into density. So if we have a bar which is 1 meter in length, okay, so volume is equal to density, volume into density, and volume we write as a area into length. And we know that for a density, for circular bar, density is equal to 7850 kg per meter cube, and this is the circular bar. So area is equal to pi by 4 into d ka square into length of bar is equal to density of bar of steel. So length of bar is the 1000 or 1 meter. So here we write all values. Pi is equal to 3.14, d is equal to d square, length of bar is equal to 1000, and density of bar is 7850 divided by 1000 into 1000 into 1000 if you convert in the mm cube. So after simplify this all equation, final equation we get d square upon 162.29. It is approximately equal to d square upon 162. Means if you want to find the weight of reinforcement per meter, simply you have to divide the diameter square of bar divided by 162. 2 means if this is the 12 mm bar, so simply you have to write 12 into 12 divided by 162, so you get the weight of 1 meter, up to 1 meter of 12 mm bar. So these all things which we used in our abstract, that's why we discuss here. Now we go to our abstract part. So here we go our abstract part, how we find the quantities of different descriptions. So first we have to find the concrete, which is the ratio of 1 ratio 1.5 ratio 3. So how we find the ratio? We know that our slab dimension is 3 meter into 8 meter. This is the inside dimension, but our slab is cast on the wall. That's why here this means this dimension is 3 and this dimension is 8, but this is the inside dimension and we count as the outside dimension. That's why our wall thickness is 230 mm, here also 230 mm. That's why we add this 0.23 on both side in length and width. So here we add 8 plus 0.23 plus 0.23, we get 8.46, and width is equal to 3 plus 0.23 plus 0.23 is equal to 3.46. So final we get here length is 8.46, width is equal to 3.46, and we know that in our question mentioned that the thickness of slab is 12 mm, so we convert in meter. So here we get 0.12 as a height. So final we multiply these quantities and get the 3.51 meter cube as a quantity of cement concrete for slab. Now after cement concrete we have to find calculation for centering and shuttering also. So for slab we have to shuttering from bottom side and from this side, from this side, from this side and from this side. So we have one bottom side, one side 1 means you count this side to this side, and side 2 this side and this side. So you get two sides here along the length or along the width. That's why here we write 2 and 2. So for bottom part, if you count the bottom part means you count the inside of the wall. So wall inside count you have to count, so 8 into 3, so we get 24. If you take value from this side to this side means you have to count the length from outside to outside. That's why here we write here 8.46 for length and 3.46 for width, and here we know that thickness of the slab 0.12 0.12. Finally we multiply these three columns, these three columns and these three columns, and get final answer and summation that, and we get 26.86 meter cube. Now we have to find reinforcement weight. How much the weight of reinforcement? So in our slab we provide different types of bars. First we provide as a main bars 12 mm dia. We have to provide distribution bars as a 6 mm dia. We have to provide bent up bars. So all bars we have to provide, but in our slab we provide a bar in a alternate bent up bars positions, means one bent up bar from that side and one bent up bar from that side, and this is our distribution bar. So first we have to count the length of straight bar and this bent up part. After finding this length, we have to multiply the number of bars and per meter weight of the reinforcement. So final we get the quantity of particular straight bars which we used as a main bar. So how we find that? First you have to find the length of straight bar. So we know that this dimension, is 3, and here 230 mm wall, 230 mm wall. So 3 plus 0.23 means from that side to that side you have 3.46. Now we have hook, means we have to provide hook. That's why here we multiply 2 into 9 into, and d is the, this is the 12 mm diameter. That's why here we convert in 12 meter, so sorry in meter. So that's why we get 0.012 as a meter, minus 2 into 0.05. 0.05 means here we take the 50 mm as a cover. So we get final is the 3.58 meter. So this is the length of straight bar. We have to add this bent up part also. That's why here we found the bent up length. We already discussed that the bent up length is equal to 0.45 x. So first we have to find the x. X is the vertical distance. This vertical distance So we know that thickness, proper thickness of the slab is 12 mm. So we convert in meter. Here we get 0.12 minus 2 into 0.02 means we have to provide cover on upside and bottom side. That's why here we minus 2.2 into 0.02 as a cover, and this is the dia of bar. So final we get 0.068, we multiply with 0.45, so get 0.03, and total length is 3.58 plus 0.03 is equal to 3.61. So 3.61 is the total length. Now we have to find number of bars. So how we find number of bars? The formula is span upon center to center spacing. So we have to find space span. So we provide this bar up to this length. So here 8.46 as a length, then deduct the cover. So we here deduct cover, so we get 8.36 meter. Means you have to provide this bar up to the 8.36 meter. So 8.36 divided by center to center distance 120 mm center to center. That's why we convert in meters. We get 0.12 as a meter plus 1 is equal to 71. So here we multiply that and get this answer. Here we do plus 1. Why? Because if you arrange the straight bar at a 120 mm center to center distance, when you go up to the end part, means center to center distance is not covered at the end bar. That's why we take one extra bar as a counting. Now same procedure we apply for the 6 mm diameter bar. Here we provide 6 mm diameter at the bottom, and here we provide 6 mm diameter at the top. So for that we have to find hook length. Hook length, we know that for hook length we have 9d as a value. So here we take 9d as a value, but you also remember that the value is not less than 10d or 75 mm. If value is less than 75 mm, you take the value as 75 mm. So here we take a value as 75 mm. We find the length of the bar and width. Here width is act as a span, and final we get the 20 as a bar. And now bars at the top. Same process we apply here and get the bars at the top is 10. So add that both bars and we get here 30 as a bar. So here we multiply this 30 with 8.51 as the length of the bar and 0.22. You know that how we find that t square upon 162, and we multiply these three columns and we get 56.17 kg. So after adding this all bars weight, we get 286.85 kg as a weight of reinforcement. So this is the all discuss about the R.C.C slab work, how we find the quantity for concrete and how we find the weight of reinforcement for a particular bar, means bent up bars, straight bar or distribution bar. Thank you.